So we were dealing rotation. This is class 3 for us. So today we will go through some more models, and thereafter we will work on toppling also in the same week itself. Please go through this question. Everyone try to please work on this question. Now you have a ladder of mass capital M and length L, and it is supported in equilibrium against a smooth vertical wall and a rough horizontal surface. Are shown in the figure. Theta is the angle of inclination of the rod with the horizontal. Then, now let us try to take the situation like this. Smooth wall and rough floor. Rough floor and smooth wall. Imagine that this is your ladder. Remember, you have one normal reaction here. We will call this end as A, and this end as B, and this makes an angle theta. NA. Remember, if it is smooth, A will have a tendency to move in which direction? If suppose floor is also smooth, what is the tendency? Backward. So friction acts on A in forward direction. Right. No, join here. So that is the first observation. You have a normal reaction at acting at A. And similarly, normal reaction acting at B like this. Right. There is no friction there. And remember, by the way, weight acts mg downwards. Now you know this is an equilibrium. Now we have sigma fx is equal to 0. So therefore F is the same as NB, equation 1. Have you received assignment for this week? So I have given not more than 60 questions. It is purely less than 60 questions. Have you started? వస్తున్నాయి ఆన్సర్ చేస్తూ ఉంటే రైట్. Next, what is the normal reaction of the ground? Sigma Fi 0. Na is equal to mg, which is equation 2. Now, can you please suggest me one point where the torque is 0? You suggest me one point. Dakshesh,
Yes, sir.
am I audible?
Yes, sir.
Right. నువ్వు ముందర కూర్చోను నాకు ఆడిబుల్ ఫ్యాక్టర్ రీచ్ అయ్యేటట్టుగా.
Yes, sir.
Right. Dakshesh, tell me which point you prefer for applying torque. Anyone in the class?
Right,
Yes,
torque.
absolutely correct. Yes, absolutely correct. Net torque about A is equal to 0. Now, this is the time 8:30. 9 o'clock, I will take toppling class actually, so that I'll complete theory first. Now, yeah, by the way, by doing which you will get mg, Are bhaiya, this is a force. line of action of force, and this distance is L by 2 cos theta. Whereas this is the line of action of force, and this distance is L sin theta. Because you know, mg times L by 2 cos theta is the torque of the weight force, and this is in clockwise sense. Whereas NB times L sin theta, this is the torque of the normal reaction, which is in anti-clockwise sense. So finally, I can write NB as mg by 2 cot theta. Three. Point number 3. Right. What do you want? So I have given everything. Normal reaction of the wall, I have given. See, try to please understand your F, which is equal to NB. This F must be less than or equal to mu NA. Right. F is NB, which is nothing but mg by 2 cot theta less than or equal to mu NA. NA is mg. Strike off this. So therefore, mu must be greater than or equal to cot theta by 2. So mu minimum required in this situation is cot theta by 2. Now I given everything whatever you require there. Now what is the net force exerted by the ground on the ladder? The ground at A will exert two forces. One is NA, which is equal to mg. The other is F, which is nothing but NB, which is nothing but mg by 2 tan cot theta. Right. So you want the resultant of these forces. This is the resultant force. So the resultant force is NA square plus F square, which mg is a common. So 1 plus cot square theta by 4. Any doubts? In fact, honestly speaking, I am drawing the same situation again. Honestly speaking, you have the rod like this, and this is angle theta, right or not? That is angle theta. So actually, in such situation, you have mg. You know what happens? The resultant of these two forces, normal reaction at A and friction, the resultant of these two will now pass through this point. And let this be point P. That is the resultant reaction force at A. And remember, normal reaction of B is also passing through the same point. And remember, weight is also passing through the same point. Now you please tell me about P. The only three forces are there actually acting on the rod, honestly. Bhavana, what are they? One is a weight force, the other is normal reaction force, the other is a resultant reaction force. Now, what are the situations that you are facing? These three forces, if you extrapolate the lines, they are intercepting at a point P, such that about P, the net torque of the system is 0. If such situation exists, it's in rotational equilibrium. So always you need to find such a point about P, NB, MG, RA are passing. In such a situation, what can you comment? Net torque about P is 0. You should get one such point, concurrent, what do you call that? Right. If that situation exists, net torque is 0. But I taught you this method last, but I taught you the basic method first. ECL students, any doubts on this?
No, sir.
రైట్ నన్ను ఒకసారి దక్షేష్ నిన్నటి క్లాస్ వీడియో చూసారంతా
No, sir.
రైట్ యూ షుడ్ హ్యావ్ గాన్ త్రూ నో ఈవినింగ్ యూ హ్యావ్ నో వర్క్ దక్షేష్ నీకు చెప్పా కదా చూడమని
Sir, నేను చూసినా కానీ వేరే రోజు వర్క్ లేదు సార్.
వాళ్ళకి చెప్పలా నువ్వు రైట్ విల్ మూవ్ ఆన్ టు దిస్ క్వశ్చన్ నౌ right. At the bottom edge of a smooth wall, an inclined plane is kept at an angle of 45 degrees. Uniform rod of length L and mass M rests on the inclined plane again as the wall, such that it is perpendicular to the incline. What is the minimum coefficient of friction necessary so that the rod does not slip on the inclined plane? Right. First, let us try to draw the free body diagram of this situation. I'll try to draw the diagram again because the space there is constrained for us. That's it. So now you have the rod AB. Now let us try to understand what exactly is happening over here. You have one force mg, one force normal reaction, another normal reaction. This is fortunately smooth wall. There is no friction here. Frankly speaking, I will extend this line. I will extend this line. Honestly speaking, you said this is 45. And there should be friction like this. So their resultant must pass through this point at least. Antega? What is the minimum coefficient of friction necessary so that the rod does not slip the inclined plane? So their resultant effect, the resultant of these two will definitely pass through this point. Only then equilibrium exists. Okay, got the point. Next. Now let us try to understand. We will take the net torque about A, because in equilibrium, you can choose any point. Net external force is zero. You can apply torque equilibrium condition about any point. Now, in this case, you will have F into length of the rod L is equal to mg times L by root 2 root 2. Yes or no? Is L by 2 root 2. Why? Therefore, friction is mg by 2 root 2. Next. One part is done. Next part, sigma Fi is 0. What are the downward forces? What are the downward forces? Only weight. Except weight, there is no downward force. What are the upward forces? Component of normal reaction. Please try to understand. You imagine a vertical line over here. Vertical line over here. This is 45. This is also 45. ఇప్పుడు మీరు నోటీస్ చేస్తున్నట్లయితే అప్వర్డ్ కాంపోనెంట్ ఎంత అవుతుంది ఎన్బి బై రూట్ 2. ఫ్రిక్షన్ కాంపోనెంట్ ఏమవుతుంది ఎఫ్ బై రూట్ 2. రైట్. ఎంజి ఈజ్ ఈక్వల్ టు ఎన్బి బై రూట్ 2 ప్లస్ ఆల్రెడీ ఫ్రిక్షన్ యూ హ్యావ్ సమ్ క్లారిటీ. ఇట్ ఈస్ ఎంజి బై 2 root 2. This will become mg by 4. Yes or no? Are bhaiya, equation 1. Use equation 1. Now what happens? NB is 3 mg by 2 root 2. I have given you NB. I have given you friction. Any doubts? Any doubts till this point? Sigma Fi is equal to 0. What do you want basically? Are bhaiya, you have NB. Very simple. Your F must be less than or equal to mu NB. That's the condition. Which means mg by 2 root 2 less than or equal to 3 mg by 2 root 2. mg cancel. 2 root 2, 2 root 2 cancel. Mu greater than or equal to 1 by 3. So therefore implies mu minimum is equal to 1 by 3. Now tell me, do you have any doubt in this? So if you wish to apply equilibrium point, that is this point. It is this point. About this, the resultant must pass through this point. No, I think I'm wrong. About this point, actually. About this point. The resultant must pass through this point. Color marutam oka nimisham. It is the point. The resultant of both need to pass through this point. Only then you will have that equilibrium condition. Let this be point P. So about P, net torque is 0 because they are concurrent at point P. Right. Any doubts? ఆర్ వి క్లియర్? రైట్. ఇంకోటి ఏంటంటే జామెట్రీని బట్టి కూడా మీరు అసలు ఇది ఇది ఒక పద్ధతి. ఇంకో పద్ధతి ఏంటంటే జామెట్రీని బట్టి కూడా మీరు చేసుకోవచ్చు. అక్కడ ట్రయాంగిల్ జామెట్రీ వేసుకుని కూడా చేసుకోవచ్చు. ఎస్టర్డే ఐ టాట్ యూ దట్ మెథడ్ యాక్చువల్లీ. ఇంత చేయనక్కర్లే యాక్చువల్గా. సి ఐ కెన్ డూ దట్ ఇన్ ఎ డిఫరెంట్ వే ఆల్సో. 1 minute. Let us call this as C. So from the triangle C, what you have? PC by this angle. Let that angle be phi. Sin phi is equal to BC by no. You know only one thing. This is 45. This is 135 degrees. Sin 135 degrees. 1 minute. This is 5. This is 135. అప్పుడు ఇది ఎంత అవుతుంది? Some delta. Delta plus 5 plus 135 degrees is 180. Delta plus 5 is 45 degrees. Correct? So you want delta. So sin 45 minus delta. BC. ఇంకేముందిరా? BP. 45 minus 5. ఇంకోటి ఏమైంది? BP by sin 135. We know PC. PC is nothing but if this is L by 2, this is L by 2 root 2. Forget about this. BP, you know, no? BP, you know. BC, you know otherwise. BC. Hello? You know BC. BC is L by 2 by sin 45 minus 5. You'll get sin 5 from this. So what if I know sin 5? Simple. In a vector quantity, this is NB and this is friction. This is phi. You can get F from that diagram because anyway you know what is F. You want to find NB, you can get it from that. You will get phi from here and that you use here. You will get NB from here. Otherwise, anything is the same answer. I am giving you two different methods of solving the same question. But I prefer this one only because if you are bad at geometry, you are out. Next. Illustration 3.30. Make it. The door of an almirah is 4 meter high, 2 meter wide, and weighs 50 kg. The door is supported by 2 hinges. Here I need to draw the door free body diagram separate. MG. There is a hinge here and there is a hinge here. So I am assuming one is FH over here. Another is FH over here because there is no horizontal force to support equilibrium. Oh yeah, that's all. What do you want? The on the hinge if you want are here, okay. This is F vertical. This is another F vertical. Whereas on the hinge free body diagram will be F vertical, F vertical. That's all. You may ask me, how do you know they are same? Simple. Remember, about this point, these two forces, these distances are same. So their torques must be same. Because these forces are same. Yes or no? These forces are same. For example, FH cross clockwise, FH also cross clockwise. In that case, FE and FE must provide anti-clockwise torques. They must be same. So that is the reason why I am telling you that they are same in magnitude. So sigma, okay, sigma F5 0 for Almara. 2 times F vertical is mg. You said that is 50 kg. So Fe is 250 Newton. 1 Fe is 250 Newtons. Done. Next, rotational equilibrium is what you want. For rotational equilibrium, you take one such point here. That is better. Why? All F's do not contribute any torque. All FH, this FH will not contribute any torque. So the torque contributing factors are one weight, the other FH. Now you know this is 1 meter. And from here, the hinges are separated by how much distance? Is it given in the question? 1 meter, 1 meter. So 2 meters. Right. So yeah, let us call this point as B. Let us call this point as A. Sigma torque about B0. So mg times 1 is FH times 2. So FH is mg by 2, which is the FH part is again how much? 250 newtons. Okay. At each hinge, the resultant force is FH square plus FV square. That will become 250 square plus 250 square, which is 250 root 2 Newton. Remember, they are very fundamental models. Very fundamental models. Right. Dakshish, what is your feedback? Is it okay?
Yes, sir.
Right. I'll complete these two questions, or if required, this one, and I'll start. In this particular question, what to do is you need to have a proper idea of drawing the free body diagram. If I draw the free body diagram of the rod, you will have one normal reaction. Let this be RA. And the normal reaction here is RB. Are they both W? Yes, they are both W. W. See, only what are the different unknowns we have is RA and RB. You require two equations actually. Let us take sigma Fi 0. In this case, the reaction at A and the reaction at B is equal to 2 times this. Now you take the torque about A, about this point. Then what happens? RB times L. This is the only, this is the only anti-clockwise torque. And the others, W times L by 4 plus W times L by 2, both are clockwise torques. So clearly RB is 3W by 4. So therefore RA is W by 4. That's all. నేను కరెక్ట్గానే రాశానా ఒక్కసారి చూడండి. No, wrong. 3W by 4, 5W by 4. Because the sum is 2W, not W. 3W by 4, 5W by 4. Are we clear? ECL students?
Yes, sir.
Right. Any doubts? That's
No,
it.
No, sir.
Right. Already we have done this question, if I am not mistaken, but still okay. Because these students have just joined. I'll complete this question. And I also told that I'll complete one more question here. With this, I will close and I will step into toppling. You have a uniform rod of length L, you can see that, and mass M is hung from 2 strings of equal length from a ceiling as shown in the figure. Determine the tensions in the strings. Now you assume the tension here is a TA and the tension here is a TB, and the weight acts vertically downwards, mg. So TA plus TB is equal to mg, equation 1. I got this from sigma Fi is equal to 0. Right. Next, one more important point, you take torques. About A torques 0. mg times L by 2 is TB times 3L by 4, which is nothing but TB is 2/3 of mg. TA is mg by 3. Any doubts? अरे easy questions कर रहा हूं मैं. Just doing easy questions. Dakshesh, any doubts?
No, sir.
Here, if you are not turning back to ask your friends.
No, sir.
Right. Right. Now, this is a major task for you. This is a major task for you. Right. Go ahead. You study this question for just 3 minutes. What are your observations in this question, first of all? I'll ask you only one question. In this, just tell me, uniform beam of mass M is inclined, of course, okay. Apparent, okay. Coefficient of static friction between the beam and the floor is only given. Means you can take this as a rounded end and this is a smooth. Remember, if that is a smooth, tension will be same in both the sides. If that is not smooth, tension is different this side and that side, because there is an IIT question. Now, I think on Friday class, I'll try to discuss, or on Saturday class, I'll try to discuss previous IIT questions. Now, let me draw the diagram carefully once again. That's your wall, and that's the floor. right? You require only one normal reaction, unless, can you please tell me the tendency of this end? Will it move leftwards or rightwards? Amma, గట్టిగా చెప్పండి, ఏం కాదు, rightwards. So obviously the friction direction will be leftwards. And you have the tension here and the tension here. Done. If we have clearly understood this free body diagram, the question is done. Now, well, let us take sigma for the rod. For the rod, sigma Fy is equal to 0. What are the upward forces? One is a normal reaction. Others are totally downwards. One is mg, the other is mg. Any doubts? Leda, Sushmita, you have a doubt. Why I have written this term? If you draw the free body diagram of the rod, this tension force acts at this point. Anagada, that is acting on the rod. That is same as capital Mg. Right. Now I am going to do sigma, let this be equation 1. So why I will use all these things is, in the course of revision, you will identify that box terms are the highlighted areas. Right. Sigma Fy is equal to 0. And sigma Fx is equal to 0 for the rod. So what are the forces? Only two forces are there. What are they? Tension and friction, which is mg is equal to friction. Let this be equation 2. Now you please tell me which point you prefer me to apply torque. If I am not mistaken, you will definitely choose this point as for the application of the torque. Ante kada. So for the application of the torque, net torque about contact is equal to 0. So that results, you said this angle is a theta. Therefore, mg L by 2 cos theta is anti-clockwise torque. And mg L cos theta is also anti-clockwise torque. And one more is also there. The other is, actually, I should write this as a T. T. UCL students, I hope you are following. T times L sin theta. So therefore, mg cos theta plus 2t cos theta is t sin theta. T capital Mg, 2t sin theta, right? So mg cos theta is 2mg times sin theta minus cos theta. ECL students, any doubt or any disturbance till now?
Disturbance.
Right. Go through these steps once and confirm. Just to go through these steps and confirm whether you understood this or not. I think there is no doubt in equation 1 for you. And you are there while I was teaching equation 2. The connection is the last while I was teaching torque. Dakshesh, correct, Anna?
Yes, sir.
Right. Now in this case, the net torque about contact point. I am applying torque about this point. In that case, mg into perpendicular distance, L by 2 cos theta. T, L cos theta. T, this is L sin theta. So I got one relation like, what do you want basically? Find the coefficient of static friction between the beam MUs, determine the expression for the maximum value of M that can be suspended from the top before the beam slips. Very clear. From this, F less than or equal to mu S into N. So mg less than or equal to mu S into N. mg less than or equal to mu S into N refers to here plus capital MG. But don't write capital MG. Avoid capital MG term. Avoid capital MG term here by writing this as mg cos theta by 2 times sin theta minus cos theta. So mg less than or equal to mu s times, this will become 2mg sin theta minus 2mg cos theta plus mg. So mg cos theta by 2 sin theta minus mg cos theta minus cos theta. So therefore, M must be less than this. M must be, because what maximum is you are asking, that's what I have the option. So in the place of capital MG, I am eliminated. That is one option. ఇంకో ఆప్షన్ ఏంటి, ఇక్కడ కూడా తీసేశారు అనుకోండి, ఫర్ ఎగ్జాంపుల్ you'll get the condition for mu s, but they are not asking the condition for mu s actually. They are asking only the relation. So what I got is mg less than or equal to small mg common తీస్తే 2 mu s sin theta minus mu s cos theta divided by sin theta minus cos theta. M less than or equal to small m by 2 times 2 mu s sin theta minus mu s cos theta by sin theta minus cos theta. That is one option. Okay. That is one option. Okay, fine. What else we have? That's what I can do with. It's a very good question actually. A really very good question. Because in the mg cos theta weight of the rod, 2t cos theta, t refers to capital Mg. That's all. మళ్ళీ కనెక్షన్ పోయింది. Yeah, I have done this question already. I've done this question, but I'll do it later. How many questions are left for us? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13. I'll delete this because we already done this. 13, 14, 14 questions ఉన్నాయి ఇంకా అందులో. That we can manage. Right. See, toppling is one condition that you need to know. It's a very simple topic actually. Simple topic. Dakshash, you received assignment, right?
Yes, sir.
Right. Next. Toppling, you can see that I just have placed a block here. And I just want to try to push this. Because the surface is rough, I can see that friction acts over here along the common tangent to the floor and the block. But in this process, what happens is the normal reaction will not pass through the center. Why? It shifts along the direction of application of force like this. Why? Imagine that this is point C. Okay. And this is at a distance x. About C, it's an equilibrium still. And remember, about C, this distance is how much? This is b by 2 distance. And this will be obviously, this distance will be obviously h minus b by 2. Clear? Right. About C, due to F, the force is h minus b by 2, and the nature of this force is in clockwise sense. Even friction will also do the same, and the friction is at a distance of b by 2. So therefore, this is also clockwise. And both the forces are clockwise. How come block stays in equilibrium? Suppose if the normal reaction pass through the center, for example. Okay. Now you accepted that there are two torques about center right now. Something need to compensate this. Okay. Then you may get an idea. Suppose normal reaction not passing through C. It has, for example, you have two options. The normal reaction may act in this direction or in this direction. Suppose if the normal reaction is acting in this direction, Bhavana, what will be the nature of the torque contributed by the normal reaction? Already రెండు clockwise ఉన్నాయి. So you require one in anti-clockwise sense. So therefore, the normal reaction will shift in this direction by a distance x. Therefore, from this, I can say that, of course, a sigma Fi0 gives n is equal to mg. And not only that, it's not moving. So therefore, the applied force and the frictional force is the same. Keeping in these points, F, small f place my F, n place mg, I have substituted. So by doing which, I got the condition like this. I'll get a condition F into H is mgx. So X is F into H by mg. This is the condition. So in this case, block does not slip and does not topple. One more important point is normal reaction shifted by X. Shifted by X. Normal reaction shifted by X. ఎంత రాస్తారు ఇది ఇది ఓన్లీ సిగ్నేచర్ కావచ్చు. ఒకసారి నేను మాట్లాడితే వస్తాను. 11 o'clockకి అట్లా వస్తాను క్యాంపస్. నేను వచ్చేటప్పుడే చేయించుకోండి. Now if F is increased gradually, not all of a sudden. Suppose if this F is 20 newtons, gradually 21, 22, 23, 24, likewise I'm increasing. The three things are possible. One, keeping F less than or equal to FL, block does not slip. But as you increase F, what happens? X also increases from this data. Arey, X cannot take any value, no. The limit for X is maximum A by 2. So in that situation, what will happen is the normal reaction starts acting at this point, that is the edge. You know what will happen is, if it is not slipping at this point, what will happen? It will topple. Means as a rotate about the P, about that point. It won't slip, but it will topple. So what is the condition for that? X is equal to A by 2 in our formula. So X is equal to A by 2, which is F into H by mg. So such an F is what you call as F is m. This is the condition. So if you apply this much force, it won't slip, will not slip, but topple about P. Right. And one more important point. X is not reaching till the edge, but F becomes FL. What happens? This is the same as our old case, loss of motion case. The block will slide without toppling. Agreed? Next case. Both happen simultaneously. Then both will happen simultaneously. It will topple with slipping. So first case, toppling without slipping. Second case, slipping without toppling. Third case, toppling along with slipping. That's the case. Any doubts? Sure. So I have given you a fundamental approach of toppling. ECL students, please confirm, have you understood this?
Yes, sir.
Right. What if you place this on an inclined plane? Another situation. What if you place this on an inclined plane? So I placed it on an inclined plane, rough inclined plane. Remember, it's not smooth, rough inclined plane. Now what happens is two possibilities. One, this is the weight force, and this is the normal reaction force, and this is the frictional force. Three forces are there. Actually, wrong, only two forces. These are the components of the resultant reaction force. If the resultant reaction force and weight force pass through the same point, no toppling, no slipping. So that is one condition. No toppling, no slipping. Next. Suppose if the resultant contact force is not passing through the center of mass. If the resultant contact force is not passing through the center of mass, rather it is passing through a line below the center of mass. Now, about the center of mass, there are only two forces. One, the weight, the other is the resultant reaction force. In this case, about this, the resultant reaction gives you what kind of torque? Anti-clockwise. So it will topple without the slipping. This comes under toppling without slipping. Similarly, the other case, it won't topple, it won't slip. Right. Now, what is that we need to see is very clear. Now, of course, I am taking the case of the edge case where the normal reaction is passing through here. You have one component mg sin theta. You have another component mg cos theta. First of all, if mu mg cos theta is greater than mg sin theta, means mu is greater than tan theta. In this case, block will not slip. And the nature of the friction there is static. This comes under static friction. Right. But in this case, block will not slip. Okay. But block will topple. Suppose if I am taking this point where mg sin theta a by 2 is greater than or equal to mg cos theta into b by 2. In this case, turning happens like this. But definitely it will topple. So if mu greater than tan theta and tan theta is less than b by 2. So I should give you a condition. Mu one minute. Mu must be greater than tan theta and tan theta must be less than b by 2. Mu is greater than tan theta is less than mu, tan theta is less than b by u. So whichever is the lowest. See, b by a and both should satisfy. Then what will happen? The block, if tan theta, here tan theta greater than, no, here tan theta greater than or equal to b by a for toppling. If mu is greater than tan theta, it won't slip. If tan theta is less than b by u, it won't topple. So what is this condition called? Block will remain at rest. No slipping and no toppling. I'll take another case. ఇక్కడ రాశాను already. Tan theta is less than b by u, mu less than or equal to tan theta. Block will slide down without toppling. Tan theta is equal to b by a, mu is equal to mu greater than tan theta. Block will not slip, but it will topple about p. Tan theta b by a, mu is equal to tan theta. What happens? It will slip along with toppling. Okay, right. So these are the basic data for this particular aspect. Now give me 1 minute time. We will deal some numericals related to the one or two numericals related. Previous record cheyaleda. Right, no issues. Yeah. Tell me. Uniform cube of side B is a cube actually. See, what should be the coefficient of friction between the cube and the table so that it will tip about an edge before it starts tipping. Very simple. Friction, normal reaction. And one more important point, almost this is the case. And try to please understand, normal reaction is passing through this point actually. About this point, we have already derived this condition. We have already derived this condition. F is equal to mga by 2h. But h at point of application of force. F is mga by 2h. A emo side, h point of application of force. I've just given, no? F is equal to mg. A ante ikkada b rayali 2 times height ante 3b by 4 rayali. అయ్యే వచ్చింది నీకు 2 by 3 mg. But F must be less than or equal to mu mg. So 2 by 3 mg must be less than or equal to mu mg. So mu greater than or equal to 2 by 3. So therefore, what should be the coefficient? Mu minimum required is 2 by 3 for this purpose. If mu minimum is not 2 by 3, what happens? It will slip before it topples, right? So what is this condition called? Toppling without slipping. That is one condition. Actually, this is a very good question. Let me pick one more. Right. 1 minute. We'll stop up here. We will complete our original flow of questions because I'll paste it later on for tomorrow. So just introduce the concept. ఇప్పుడు మనకి ఇచ్చిన అసైన్మెంట్ ఏమైనా ఉన్నాయా? అసైన్మెంట్, ఎనీ అసైన్మెంట్ క్వశ్చన్స్ రిలేటెడ్ టు toppling, just see. Yes, we have one question. So in this process, I can make sure that your homework is also taken care. Yes. You please work on this now. A cubical block having square cross section. Go through that. Square cross section, Nana. Now, what makes this to topple? That's the first question. You should start with that approach. What makes it to topple? Unless or until you don't have any idea why it is happening, you cannot do the question properly. You need to know what makes it to topple, right? Cubical block having square cross section of side 2 meter and of mass m is equal to 10 kg is resting over a platform moving with constant acceleration of A is equal to 1 meter per. Coefficient of friction between the block and the platform is a force F acts at the top of the cube as shown in the figure. Then, first of all, leave this question as a toppling based question. What is the condition that it won't slip? The block will neither slide nor slipping for a force of 8 newtons. Let me work. Now see, my point is very clear. You said you are studying this in the ground flame. You said mass is a 10 kg, if I'm not mistaken. Therefore, in this reference frame, this will experience a 10 Newton force. This is the pseudo force. Agreed? Right. Next point, mu is 0.1. The utmost limiting value is 10 newtons. 0.1 into 10 kg into 10. Right. Right. So obviously, this 10 Newton, and if there is no external for I'm speaking about, the F limiting is a 10 newtons. So in this case, it is just exactly at the edge situation. But now you are applying another force on that. So maximum condition in that case, this is the case when F is equal to 0 situation. And you are applying a force. Already you have a pseudo force, 10 Newton pseudo force. And now the limiting friction changes the direction to this side, 20 Newton. And that is F. Your F must be less than or equal to 10 plus 10. Okay? Yes or no? In that case, F is less than or equal to 20 Newton. If your force is less than 20 Newton, what will happen is A relative will be 0. Because this will adjust according to this force. So therefore, now what is the first condition? Block will neither sliding nor slipping for a force of 80 newtons. Correct again? Yes or no? You are not believing me. Then you should take the first. Already you know it should be less than or equal to 20 newtons. Block will slide without toppling for a force of 45 newtons. Greater than 20, so it will slide. But whether it will topple or not, that I need to check. Now, in the reference frame, you cannot change the acceleration of the lower one. That is fixed, 2 meters per second square. Now, according to me, the block is experiencing whatever, this is a pseudo force, 10 newtons. And that is some 1 minute. You applied how much force? You applied 45 newtons force. And of course, you cannot change the friction, and that will be 10 newtons. Let me just check once. If I study the situation, the net force in this direction is 35 Newton. and the friction is 10 Newton. So about this point, we will calculate torques. Torque 35 into A by 2 because this is A by 2. And what is the weight torque? Weight torque. What is the weight torque? 100 newtons into A by 2. Now tell me, will it topple? Boys, weight torque is 100 times A by 2. Applied force, net applied force 35. No. What will happen? It will slip without toppling. Right. Right. Now what if it is a 60 newtons? What if it is a 60 newton? Let me work. First of all, let us do the problem in a different way. Oh. Already we know if it is more than 20. Why I'm unable to mark? Right. ECL students, I think you are following. Now I will take a general case. F. This F is greater than 20 newtons. Obviously, the friction will be 10 newtons. Okay, right. The normal reaction expected to pass from here. And mg is equal to 100 newtons. But here this is A by 2 and this is also A by 2 because it's a cube. And by the way, there is an acceleration for this. There is an acceleration for this, some A. If I said A, it is already slipping, right? And F minus a pseudo force. You said what is the acceleration? 1 meter per second. So 10. So what case you want? F minus 10 times F minus 10 times. What if it is moving A relative? A relative. One minute. That is a 2 meters. Even you can mark D also here because it is less than 20 newtons. You can mark D also. Arya, 1 minute. I am going to close C. Just give me 1 minute time. Give me 1 minute time. Am I marking everything properly or not? That I am just saying. This is A relative. What are the torque contributing factors that I need to work? Suppose if I am applying about the center. Okay. Torques. So you want the toppling case. F minus 10 times A 0. F minus 10 times 0. Okay. Plus F times A by 2. Is equal to, this is not contributing torque, weight is not contributing torque. and n times a by 2. F is equal to n. But is it possible? F is not possible to n. No. F maximum has a limit. So I doubt on the mass of the block. I can confidently say about ABD, but I am not sure about C. Okay. Paper entire in the assignment, wherever you have topic questions, don't do. I'll do it in the class. Right. Eighth question. Everyone, please go through eighth question. In two papers, you have only one question actually. Ante. Yes, we have already done this question, but okay. The ladder shown in the figure has negligible mass, rests on a frictionless core. The crossbar connects the two legs of the ladder are at the middle. We have almost done the same question yesterday. The angle between the two legs is 60 degrees. The fat person sitting on the ladder has a mass 80 kg. Find the contact forces exerted by the floor on each leg. Now you take only the, do you remember yesterday we took only the left arm? Now you have normal reaction like this. What about the floor here? Frictionless floor. No friction here. Center tension. Are bhaiya, there is no mass for the ladder. At the hinge, you may have two forces at each rod. One we will take as Fy, and the other we will take as Fx. This is the free body diagram of AB. AB. Right? So, very simple. Fx is equal to T, equation 1, because sigma Fx is equal to 0. Sigma Fy 0, Fy is equal to N, equation 2. The best thing what we can do is, of course, Fy, 2 Fy for the man, 2 times Fy is mg. Right. Right. You want to find tension. Got the point. Right. And no, just suggest me any point about which I can apply torque. I can apply torque about this point. But in this case, now you said this is 1 meter already. And you said this is 1 meter already. And you said this is a 30 degrees. If this is a 30 and this is a 2 meters, this is 2 tan 30. About this point, if I apply torque, tension times 1 meter is equal to N times 2 tan 30. Tension times N means Fy. Fy means mg by 2 into 2, 1 by root 3. So the answer is mg by root 3. What is what is his mass? 80 kgs. So the tension is 800 by root 3. That's all. You want only tension, na? Oh, you want normal reaction. Oh, come on here. 2n is mg. N is mg by 2. 400 Newton. Okay, I've done both. So H.C. Verma also you have this question. Very standard question. Our people might ask such questions. If you have any doubt on this, please ask. Sure? Right. Next. Are Dakshish? వెళ్ళిపోయారా క్లాస్ టైం అయిపోయింది కదా రైట్ 9th క్వశ్చన్ so you need to solve this question very carefully actually. Figure shows a vertical force applied tangentially to a uniform cylinder of weight Fg. The coefficient of static friction between the cylinder and all surfaces is 0.5. In terms of Fg, find the maximum force Fp that can be applied that does not cause the cylinder to rotate. Please try to draw the free body diagram carefully. Right. Now, in this case, this is P. Now, it will tend to rotate in this direction. Yes or no? About the center, the tendency of rotation is clockwise. But at this point, you will have friction F1 like this. And you will have normal reaction N1. Remember, here there is a contact surface. At this contact surface also, you will have friction F2. And you will have one more normal reaction N2. What do you want? Find the maximum force P that can be applied that does not cause the cylinder to rotate. Net torque must be 0, right? Before that, before I go for net torque, sigma Fy 0 means P plus F2 plus N1 is mg. Sigma Fx 0 means F1 is N2. Right. Two. Now you need to take the net torque. If you take about this point, the net torque about the center you take, P is F1 plus F2. P into R is F1R plus F2R. So P is F1 plus F2. 3. Totally 3 equations. How many unknowns were there? F1 is one unknown, F2 is another unknown, N1 is another unknown, N2 is another unknown. But how many equations I got there? Only 3. Okay. And one more. The coefficient of static weight is cylinder and all surfaces 0.5. Right. And one more important point. F1 is mu N1, which means 1/2 N1. Leave it. F2 is mu N2, which is N2/2. But you said F1 is N2 actually. Remember? So therefore, F1, now using this observation, N1/2 is N2. N1/2 is N2. I got one more observation. Now I'm going to use equation 1 now. Equation 1 implies P plus F2. Can you please tell me what is F2? F2 is N2/2. Can you please tell me what is N1 now? 2N1. No. 2N2 is equal to mg. But on the other hand, P can also be written as F1 plus F2, right? P can be written as P is, I'll change the color to avoid confusion. F1 N1/2, F2 N2/2. F2 is N2, mu N2/2. By writing N1/2 as N2, this can be written as a 3N2/2. So therefore, from these two equations, you can conclude that 3N2/2 plus 5N2/2 is mg. 4N2 is mg, or N2 is mg/4. N1 is 2N2, mg/2. So in fact, P is 3mg/4. What do you want? That's all. I have done that. P is 3mg/4. Are we clear on this? 3mg/4. The only thing that you need to worry is how to use these equations. That's all. So this is the major zone. Okay. Next. ఇంకేమైనా ఉందా? అదేంటో mg/2 plus mg/4. Anything, is there anything wrong in N2? ఎదురా N2 top N1 3mg/8. Oh, P is 3N2/8. Correct. 3mg/8. Done. We are done. ఇంకా మనకి ఎన్ని ఉన్నాయంటే ఇవి బేసిక్, ఇంకా హయ్యర్ ఆర్డర్ మోడల్స్ ఉన్నాయి. రైట్.